were going to tell me about one-piece flow. That's right. Remember last time how we talked about flow? Oh yeah, that's how materials and information flow through your value stream. That's right. One-piece flow means moving product through your process one unit at a time, without waiting, batching, or piling up inventory. When it works, it exposes problems quickly, stabilizes quality, and drastically reduces lead time. That's really impressive. But what do you mean by batching? Batching is the opposite of one-piece flow. This is where you build up multiple parts, or a batch, before you send them on to the next process. Okay, but how does that impact flow? I mean, the parts are still moving, ain't they? They are, but we have to wait until the batch is finished before we can process the next step. So the batch really becomes inventory. Hey, inventory and waiting are 2 of the 8 wastes. And if you built extra batches, that would be overproducing. Yes, you're getting the hang of this. Thanks. But how is one-piece flow better? One-piece flow keeps things constantly moving rather than starting and stopping. Let me show you what I mean.
Imagine we have a process that requires 5 separate operations. Each operation has a cycle time of 1 minute. The parts are built in lots, or batches, of 5 pieces. On the time clock in the upper right-hand corner, we will keep track of our time. The line starts with no work in process, or WIP. Operation 1 makes a hole in the part. Since each operation takes 1 minute to make a part, it will take us 5 minutes to build 1 batch. Now we add 5 minutes to the timer and move the batch to operation number 2. At operation 2, we add 3 bolts to the part. 5 parts require 5 more minutes of operation time. The batch is now ready to move to operation 3, and we add 5 more minutes to our timer. It has now taken us 10 minutes to complete 2 operations. At operation 3, we cut a slot in the part. Again, it takes 5 minutes to complete the batch. Once the 5 parts have slots, we are ready to move the batch to operation 4 and add 5 more minutes to the timer. We are now at 15 minutes of total processing time. Operation 4 notches the part in the lower left corner. It takes 5 more minutes to notch 5 parts. The batch is then moved to operation 5, and we add 5 more minutes to our timer. This puts us at 20 minutes of operation time. At operation 5, we change the middle bolt on the right side to a Phillips head screw. Like the other operations, this takes 1 minute per part, so it takes us 5 more minutes to complete the batch. We can now move the batch of 5 pieces to finished goods and add the final 5 minutes to our timer. It took us 25 minutes to create the first box of finished parts. Each operation had to wait on the previous operation to complete its batch. If you add up each station's wait time, that is 50 minutes of idle time. Using batch flow, we also have at least 5 pieces of inventory at each operation. If a defect occurs at operation 2 but is not detected until operation 5, we will have at least 20 defective parts.
Of course, each station would continue to produce parts, but the batches themselves would take longer to flow through the value stream. That is a lot of waste, but how does one-piece flow make it any better?
Now let's see what impact a one-piece flow will have on this process. We still have our timer and our same 5 operations. But instead of using 5 pieces, our lot size is 1 piece. The cycle time is still 1 minute per piece. Our finished goods container is now at the end of the line. Operation 1 makes a hole in the first piece. This takes 1 minute. This piece moves to operation 2 and we add 1 minute to our timer. Operation 2 adds the 3 bolts to the piece while operation 1 starts the next piece. The pieces move to the next operation and 1 minute is added to the timer. We are now at 2 minutes. Operation 3 cuts a slot, Operation 2 adds 3 bolts, and Operation 1 creates a hole. The pieces move to the next operation and a minute is added to the timer. We are now at 3 minutes. Operation 4 notches the piece, Operation 3 cuts a slot, Operation 2 adds 3 bolts, and Operation 1 creates a hole. The pieces advance and another minute is added to the timer. We now have 4 minutes of operation time. Operation 5 exchanges a Phillips head screw for the middle bolt. Operation 4 notches the piece, Operation 3 cuts a slot, Operation 2 adds 3 bolts, and Operation 1 creates a hole. The pieces move to the next operation and we add a minute to our timer. At 5 minutes, we have placed our first piece in the finished goods container. All 5 operations complete their tasks. Each piece moves, and at 6 minutes we have put our second piece in the finished goods box. The operations complete their tasks again. Each piece moves, and at 7 minutes we have put our third piece in the finished goods box. The operations complete their tasks again. Each piece moves, and at 8 minutes we have put our fourth piece in the finished goods box. The stations each complete their tasks. Each piece moves, and at 9 minutes we have put our final piece in the finished goods box. Remember, it took us 25 minutes to complete the first lot of 5 pieces using the batch flow. Using one-piece flow, our finished goods box was completed in just 9 minutes. With the batch flow, we had 25 pieces of inventory in the line, 5 pieces at each operation. With one-piece flow, we only have 1 piece at each operation. This means our WIP, or work in process, is only 5 pieces.
That is a huge difference. It really is. Waste hides in the gaps. The waiting, the batching, the rework, the handoffs. One-piece flow eliminates all of those hiding places.
When flow improves, lead time drops dramatically. Quality improves because defects are caught immediately. WIP inventory shrinks. Operators spend less time walking, searching, or waiting. Problems surface in real time instead of much later.
Well, that sounds all great and everything, but what does it take to get one-piece flow? It takes effort and planning. One-piece flow doesn't happen by accident. It takes a disciplined and stable process to be able to do one-piece flow.
Standard work so every operator performs tasks consistently. Balanced workloads so no step becomes a bottleneck. Short changeovers to avoid batching just to save setup time. 5S and visual controls to keep the workspace clean and abnormalities obvious. Pull systems so upstream only produces what downstream actually needs.
There's that pull system you keep talking about. What exactly is that? I think we're out of time. We'll have to discuss that in another video.
Thank you for watching this video. If you found it interesting, please click the like button. If you want to see more like this, please subscribe. It really helps out the channel.